Welcome to the 9th lecture on MIPS 32 instruction set. So, in this lecture we will be seeing the instruction set of MIPS 32. That means, the various kinds of instructions that are possible in MIPS 32. So, broadly instructions in MIPS can be classified into load store instructions, arithmetic and logic instructions, jump and branch. We have some miscellaneous instructions and some coprocessor instructions, and all instructions, as I said, can be encoded in 32 bits. Now, let us see what is this word alignment. That is alignment of the words in memory. MIPS always requires that all the words that we store in memory must be aligned to word boundaries. That means, must start from an address that is some multiple of 4. So, you see the first address, which is 0000, it starts from here, then 0004, then 28, C, again 0, 4, 8 and so on. So, must start from an address that is some multiple of 4. So, you can see all these are multiple of 4 from where it is starting. So, the last 2 bits of the address must be 00. You consider 4, last 2 bit will be 0100, 8, 1000, C as well, and all others. So, it allows a word to be fetched in a single cycle. So, in a single cycle we access this word and we get this entire word in one cycle. So, this is why we say that MIPS requires that the words to be aligned in the memory. So, if we store the words in this fashion, we can get the word in a single clock cycle, which is very essential. Now, here the first word is aligned, but see the next word, it is not aligned because it is not starting with this address, it is starting with the 5th one. Similar way, this word 3 and word 4 both are not aligned, only first word W1 is aligned. So, we have been discussing about load store architecture for quite often. What does it mean? That all operations are performed on operands held in the processor register. So, only 2 instructions can load the data from memory or it can store the data into the memory. No other instruction can use memory location, only load and store can use it. So, there are various types of load store instruction, each of which can be used for a particular purpose. Like we can load a word, we can load a byte, or we can load a half word. In the same way, we can also store a word, we can store a half word, we can store a byte. By specifying whether the operand is signed or unsigned, we can also load a half word unsigned, load a byte unsigned. Here we have another set of instructions which are used for accessing fields that are not word aligned. So, the instruction that are used are load word left and load word right, store word left and store word right. And there are some other instructions as well, like atomic memory updates for read, modify, write instruction. So, just think of an instruction which requires to be completed fully, like when we read it, we modify it and we write back it, at the same go. So, we cannot have it that we read it, we update it, we do not update it. If we read it, we have to update it and then we can store back. So, those are atomic operations. Let us see the data sizes that can be accessed through load and store. These are the data sizes that can be accessed through load and store, but load unsigned you can only use byte and half word, and this word can be done only for MIPS 64 and store can be done for all. Now, we can see some more instructions. LB is load byte, this is load byte unsigned, load half word and so on. And here for an unaligned one, we have load word left, load word right, and similar way store word left and store word right. And also for atomic update, we have load linked word and store conditional word. Let us move on with arithmetic and logic instructions. So, MIPS 32 has a wide variety of arithmetic and logic instructions, can broadly classified into the following categories. So, the categories include ALU immediate, ALU with 3 operand is possible, ALU with 2 operand, shift and multiply and divide. So, let us see this set of arithmetic operation. This is add immediate word. This is add immediate unsigned word. This is load upper immediate. This is OR immediate. This is set on less than immediate. So, let us take an example of this set on less than immediate. So, you can see that set on less than immediate, the meaning of which is if S2 is less than this immediate value 10, then you set S1 to 1, else you set S1 to 0. So, set on less than immediate. If the value is less than immediate, S2 is less than immediate, then set this particular value, that is S1. We have 3 operand instructions where these are add unsigned, and, nor, set less than unsigned, sub unsigned, XOR. And 2 operand we have these instructions CLO, that is count leading ones in a word or count leading zeros in a word. So, these instructions are also sometimes required for various programming. We have another set of instruction, that is rotate a word, rotating a word. So, we can rotate a word right, we can rotate a word with a variable. So, we can specify that how many bits we need to rotate. We can shift a word left logical, that is we can do a logical shift. We can shift a word left logical and we can specify the variable, and similarly we can do it for shifting a word right arithmetic, shifting a word right with arithmetic right shift, and with arithmetic right shift with some variable, and we can also do logical right shift. Let us move on and see multiply and divide instructions. So, the next set of instruction that MIPS 32 instruction set is having is multiply and divide. So, when two 32 numbers are multiplied, we can get a 64-bit product, and after division also you may have to store a 32-bit quotient and a 32-bit remainder. So, in this case where we will store this 64-bit result. So, we have a register called high low. This is a register pair. So, for multiplication, the low half of the product is loaded in low, while high half is loaded in high. Multiply and multiply subtract also produces a 64-bit product, and adds or subtract the product from the concatenated value of high and low. And also divide produces a quotient that is loaded into low and a remainder that is loaded into high. There is only one exception, that for the multiplication instruction, which delivers the lower half of the result directly to GPR, because it is useful for the situation when the product is expected, because when we multiply two numbers, always the result may not be 64-bit. The result can fit into 32-bit as well. So, in that case, there is an exception with mul instruction. So, these are the various instructions that I am talking about: div, divide with unsigned word, multiply and add word. So, what is this multiply and add word? Let us see this instruction. Multiply and add, meaning we are multiplying, we have 3 operand here. So, we are multiplying S2 and S3 and we are adding with S1, and also we are storing the result in S1. So, such kind of instructions are required in digital signal processing. So, this kind of instructions are very much useful and it is supported in MIPS32 architecture. So, we have various move from high, move from low, you have various multiply word to a register. This is generally used, multiply a word, multiply unsigned word. Next set of instruction is jump and branch instructions. The following types of jump and branch instructions are supported in MIPS32. We know that whenever we wanted to perform some kind of branching, so in a program we have loops. So, for those we require jump and branch instructions. So, jump and branch instruction, we have PC relative to conditional branch, a 16-bit offset is added to PC, or in a unconditional branch, a 28-bit offset is added to PC. There can be absolute unconditional branch, where the absolute address can be provided in the register, and special jump functions that link the return address in R31. So, we are jumping from one location to another, and after executing that particular location, we have to come back to the previous one. So, the value of the PC must be loaded with that return address value. So, in this context, we have some instruction. This is unconditional branch, jump and link exchange, and these are some unconditional jump using absolute address. So, jump and link register with hazard barrier. So, you will be seeing some of these instructions when you will be studying pipelining in course of time. So, relative to PC, there are some instruction branch if equal, branch if not equal. We will see that we will come across these kind of branch instruction very frequently when we use some programming. And there are some PC relative conditional branch comparing with 0. So, branch on greater than or equal to 0, or branch on greater than or equal to 0 and link. We have few branch on greater than 0, branch on less than equal to 0. So, we have various instructions that we may use for our programming constructs. We also have some miscellaneous instructions, like these instructions are used for various specific machine control purposes, and they include some exceptional instructions, conditional move instruction, some prefetch instructions are also there, no operation instructions. So, we will again see that some of these instruction no operations may be used in pipeline for some purposes. So, system call. Syscall is something which we will be using it often in programming any assembly language code. In MIPS, the simulator that we will be using is QtSpim, where we will be seeing that we will be using this system call, which is syscall. And there can be some instruction like trap, trap in equal, trap if greater than or equal, trap if greater than or equal unsigned, and so on. So, these are some OS related instructions which are used if you want to get some OS, if you want to request OS for some requirement, and then the OS takes care of it. So, these are also various kind of trap on condition comparing with an immediate value. These are some of those instructions, and this is prefetch and no operation. Next set of instruction is coprocessor instructions. So, the MIPS architecture defines 4 coprocessor. So, it is designated as coprocessor 0, 1, 2 and 3. So, coprocessor 0 is incorporated within the CPU chip, and this also supports the virtual memory system and exceptional handling. CP0, that is coprocessor 0, is also referred to as system control coprocessor. Now, there are these 4 coprocessor. It may not be used for all, but like coprocessor 1 is reserved for floating point coprocessor. Coprocessor 2 is available for specific implementations, and coprocessor 3 can be used for future extension. So, we really do not know that which kind of coprocessor we will be using in near future. So, for that reason we need some coprocessor that can be available in future, and these instructions are not discussed here. So, we are just saying that we will have some kind of instructions like coprocessor instructions. So, MIPS architecture also support a set of floating point registers and floating point instructions, which shall be discussed later. So, we came through end of lecture 9, where we discussed the various kind of instructions that are there in MIPS 32 architecture. Thank you.